Okay, so let's just look at some ideas around how to approach pulley problems. And I'm going to just look at two situations where we have a very simple basic pulley system with two objects. And then I'm going to make it a little more complicated with three objects just to point out one difference. And then you will have more videos attached where you can look at how to do this. So, so what do we do when we deal with a pulley question? So the first thing we need to do is always to identify forces on all objects involved. So in this case, my pulley, I think this object has Fg1 force, and I think there must be some tension there, which is created in that rope. Now, object 2, the bigger one, will have also Fg2, right? But there will be also reaction to this tension, T. So those two tensions in that rope, this is a classic example of action-reaction. If this object is pulling on this one is pulling back on it. So these two tensions are identical. So the next thing is we're going to decide where do we think this is moving. And we can widely guess, but I think it would be extremely intuitive to say, hey, I think it's going to move this way. Okay? I think it's going to accelerate this way. And what I'm going to do here is, for me, I'm going to write little notes and I'm going to say, well, this means that this object needs to be moving down and this one's going to move up, right? And so, again, if I decided this direction wrong, at the end I would come with negative values. But you know, if this is heavier, it's a known brainer that it's going to move down that way. So in this case, now we identified the direction where we think it's moving, and that's important for us because that tells me, well, if this is moving down, it's accelerating, then net force has to be down. That will also mean that this force has to be bigger than this tension, right? That also means that in this object, this tension is going to be actually greater than the gravity pulling it down. Right? So, first step, identify forces, then identify direction of motion, and the next thing we will do is we will set up equation for each object. So let's say this is my object 1. So for that one, I'm going to say, well, if it's moving up, that means tension minus Fg1 is equal to object M times the acceleration. For the second object, now I'm going to say Fg2 minus tension is equal to mass times acceleration. So the other thing is these two accelerations are equal. Right? If they're connected through a rope, they have to accelerate at the same rate. So these are essentially my equations that give me relationship between all forces that are involved. And depending on the situation, you could be asked to calculate acceleration, you could be told what the acceleration is, and maybe you would be calculating the tension or the mass of the one pulley. So essentially, you could get any variation of this problem. But this is essentially how you set up the equation. So now let's look at this question here next. And this is where I made things a little bit more complicated. Well, now we know, okay, so Fg3, and let's call it tension, okay? So let's call this M3. So, okay, there you go. Now, here's the trick. For this one, let's call it Fg2, and the reaction force to this tension is T, and that's my object M2. But now let's look at object 1, M1, and again it's going to have Fg1, but now here's a tension that I'm going to call T1. Now this object here, M1 pulls only on M2, right? It's not holding on to this one. Indirectly through the system it is, but what we have to add here is the reaction force to this tension T1, right? So those action-reaction forces are always between the two objects that are connected through that rope. These two tensions are equal, these two are equal, but may be different in value compared to this one. Okay, so what am I going to do next? I'm going to set up my acceleration. I'm going to say, hey, I think it's going to move this way. That means these two are moving down. This one is moving up, F net. So let's set up equation for each object. So for object 1, which is the bottom one here, well, if it's moving down, that means FG1 has to be bigger than what is opposing it. And what is opposing it is the tension 1. And I believe that's it. There's no other opposition. And that would equal to M1A. For the second object, now this is where it's a little bit tricky, because now I have two forces here, right? It's the gravity, but it's also this tension. So what I'm going to do here is I'm going to say, well, those two have to win. So T1 plus Fg2 minus what is opposing it is now that other tension is equal to M2A. And for the third object, if that one is moving up, that means tension minus Fg3 is equal to M3A. And these are my equations for the system of 3 pulleys, right? So again, acceleration is equal, just like on this side here. But I think the crucial difference here is to show that idea that if you have additional object, there is another tension here. That tension is equal from perspective of action-reaction, but might be different. How is this intuitive? Just think about it. If you were holding these two objects and you would put your hand here and hold it, you would have to apply different force than if you just put your hand here, right? And now on top of it, it's even moving. So this would be now the set of 3 equations with 3 unknowns, which is your acceleration, tension 1, and the other tension. And again, you would just solve the set of the equations. So this is basically any approach of anything like pulley. And if you look at the videos below, you will see that, now those pulleys could be on a table at the right angles in any way, but this is the basic idea. Set up equation for each object, solve the system of equations.